Maths Topic by Topic. Today, one of the least favourite ones is looking at similar shapes, looking at the length, looking at the area, and looking at the volume. Quite a lot of students find this quite difficult. It's not really that hard, as long as you follow simple rules. So let's have a look and start seeing how we can do this. And in fact, when you're doing this with the calculator can help you quite a lot. So let's have a go. So let's draw in a couple of triangles, and let's have this triangle, and we're going to compare that with a little triangle. I'll use just a template to try and make them look a little bit better. So I've got two triangles, and we're told that certain sizes are here. So let's say this side is going to be 7 and that's going to be 5, and if this side is 6, what is that side going to be? So we've got a relationship of this side to this side is going to be the same relationship as is the 6 to the unknown. This can be solved in a calculator quite easily. So I've got A is related, if I like, to B, so we'll label that side A, to B is in the same way as 6 is to the unknown. And if we look up on our calculator, we can cheat, because this calculator, get that out of the way, has on it a menu, and in the menu we've got this type of ratio, and it's in fact number 2 that I want to look at. A to B is the same as C to the unknown, so I'm going to choose number 2, and I can put these in, and I can say that 7 is to 5, as is 6 is to 30 over 7, 4.28, and so I can put that in, and my calculator has solved the problem. That's quite nice, really. And if I then knew what a different side was, then we could work out what that side is going to be, and that would just be using the function round the other way. That's not too bad. So when we're looking at these systems, we've got basically this idea of a line related to another line. So let's draw in a line. Let's have this one as 5 centimeters, and we'll have this line as 2 centimeters. Now, if I've got these lines in some sort of known relationship, I can work out other factors in the same way. So if I've got one length to a length, then we can work out what something else is to something else. And let's put in one that we can work out fairly easily. And I'm going to draw a line in now. That's 2.5 centimetres. And I'd like to know what its equivalent is going to be here. The same type of problem we've got there. We could solve it with the calculator, but let's not try and do that. Now, what can we do with this? Well, we can see that the fact this one is half of this, so therefore that one is going to be half of that. So how could we do that? Well, I could do my 2.5 divided by 5, that's going to give me my half, and then I could times that by 2. So 2.5 over 5 is going to give me a half. Half times 2 is going to give me 1 centimetre, which is what this one is going to be. So we can see that this number over that number is the same as this number over that number. Well, let's try a couple of these out and see what we can do. So let's see if we can look at a couple of triangles and see what we can say about them. So let's draw in a couple of other triangles, and I'm going to try and draw in a larger triangle and a smaller triangle. Unfortunately, this is not going to give me a nice relationship as we had before. You can see we've got two similar triangles. Okay, so let's suppose we have some sides for these. This is 10, and this is going to be, let's say, I don't know, we're going to make it up, we're going to have 5, and let's say this side is going to be, let's do it this way, let's have 4, and we've got to try and work out what that side is. So we'll do it round the other way. We can use the calculator, or we can use the other way. Let's try both. Now, what I've got is this relationship of 10 to 5, and I want to go to 4 to the other one. So what are we going to have? Well, we're going to have this relationship, and it doesn't really matter in fact how we do this. This is 10 over 5 is the same as something over 4. And this is what confuses students, that they could think of this one as 5 over 10 is the same relationship as 4 over something. They are really the same sort of thing that we're trying to work out. Now, if we decide that these are equal to one another, then this is the easier sum to try and solve, because this is 10 then over 5, and I'll take the divide by 4, and I'm going to multiply both sides by 4, and let's see what we get. So we've got 10 over 5 times 4. Let's have a look and see what we got. I'm going to put myself back into menu 1, which is the ordinary calculator mode, and we're going to have 10 over 5 times 4, and that hopefully will give us the number 8, which it does. I've set this up that if that is half of that, then this is going to be double that one. So that's double that. This will be double that. We can see that working. If we did that on the calculator, then we would this time use the other way round, because what I want to do is menu, let's call that ratio, and what we're going to use this time is the first one, because I've got here 10 on this triangle, 5 on the other one, and then we don't know what the other one is, but we know this side is 4, and that gives us 8. So the calculator solves this in the same way that we've done. So we can try to have a look at these triangles. Now, they don't always make things easy, so let's have a look at what someone could do to make our life a little bit harder. So a common way of doing this is they give you a little triangle. I've caught this thing in like this. And let's take another line that's parallel to this one. I'm going to put it here. So that's given me 2 parallel lines. We might be told what this is. This could be, for instance, 30 centimeters, and we could be told that this side is going to be 20 centimeters and this one's going to be 8 centimeters. And we might be asked to try and show that perhaps these 2 triangles might be similar. In fact, they are going to be similar, because if this is our parallel line, this is the same shape as the other triangle, so it's going to work out. And what we might be told is, well, if this side is perhaps 5, can you calculate what the length of that one is? Well, it looks hard, but it's exactly the same as this problem. Now we can make our life easier here by thinking of this as 2 triangles. So I've got the large triangle, so I'm catching this, causing problems for myself, and I've got a much smaller triangle of the same shape, trying to draw them a little bit parallel to one another. So let's see what we know. We know this side is 30, we know this side is 20, we know that this side is 8 and this side is 5. So what I can do then is work out that we've got this relationship, so I could work out what the length of that side is. So doesn't matter which way I want to try and do it, but I've got here 8 here is to 20, I'll do as a dot I suppose, is the same as 5 is to question mark. So let's have a go at doing that one on the calculator. Now, which way round is this going to be? We've got 8 to 20 as my number is to x. That's what we've got. That same way of doing it. A is to B as C is to my unknown. So let's choose option 2 on the calculator and we can do this. So we've got 8 to 20 is the same as C, which is in this case 5, is to 25 over 2, which is 12 and a half. And so I can put in 12.5 here, which is in fact the distance I needed to show there. So we've got 2 similar triangles. And there are a whole load of different problems that we can meet trying to do this. Very sort of popular things to choose in exams to try and get you to compare one shape with another. Sometimes they'll write them out slightly differently and they might give you something to prove with a couple of triangles, and let's just try and draw in a couple of triangles. So we've got this one, and we'll have, let's have a larger one this time. So there's my angle there. So let's suppose we're told that this angle is 65 degrees and this one is 65 degrees. We might be told that this side is 4 and this side is 12. So we can see that we've got an angle the same. And if I'm then told that this side is 3, can I calculate what that one is? We've got again that same relationship, that 4 is to 12 is the same as 3 is to question mark. And we could put that straight away into the calculator. It's the same way that we did the last one. So it's going to be option 2 here, and I can put these in, which is 4 is to 12 as 3 is to, and it says there 9. And so this length is going to be 9. So another way of trying to do these sort of things. Now, what can they do to make your life more difficult? Well, that was just looking at how two sides are related. But let's suppose we're asked to look at the area of some shapes. And let me draw in a couple of little squares. So I've got here a little square, and let's try another square. How are these two shapes related? Well, they're both squares. This side, let's say, is going to have a side length of 2, and this is going to have a side length of 4. So therefore this side is going to also have a length of 2, and this one's also going to have a length of 4. How are the areas related to one another? Well, we know the sides are simply related that they're double, but let's look at the area. This is 2 times 2, which is 4, whereas this one is going to be 4 times 4, which is going to give us 16. The areas here are related by 4 to 16. Now, because we're working in areas, we are always thinking about square numbers. And so we can always think about, if I've got an area, and especially if this is something like a square, then if I wanted to go from one to the other, then we would need to do the opposite of the square, which is to do the square root. So looking at this one another way, this is 2 squared equals 4, and this one is 4 squared equals 16. If I square root 16, I get 4. If I square root 4, I get 2, and then we've got the relationship of 4 to 2, which tells me that this one is double the size of the other one. So would this work if we didn't have something like a square, but we had perhaps a couple of rectangles? And the answer is, well, it should do. So let's have a look at a couple of rectangles. So let me draw in a rectangle, and let's have a smaller rectangle. Let's suppose this length here is 8, and this length here is 2. Then we know there's a linear scale factor, just one side here, of a relationship of 8 to 2. They don't look it, I know, but we've got a relationship here of this one is 4 times the size of the other one. Now let's suppose we've got an area for this one, and let's say the area of this one is going to be 2 centimeters squared. Can I work out what the area of that one is going to be? Well, the linear scale factor here is going to be the side of the large over the small, and that gave us 8 over 2, which is going to give us a factor of here of something basically it's going to be 4 times as large. So the area scale factor is going to be 4 squared because it's going to be related to this length as well. So our area scale factor is going to be a square, which is going to be 4 squared, which is going to give us 16. So the area of the large rectangle is going to equal the area of the small rectangle times by the area scale factor. So the area of the large is going to be the area of the small, so this is the one I want to work out. It's going to be the area of the small, which is 2, times the scale factor, which is 16, which gives us 32 centimetre squared. I don't know if you like that. Let's look at perhaps a different shape and see whether we get these sort of problems occurring with other shapes, because the answer is we certainly do. Let's take 2 horrible shapes. We'll take a couple of ellipses. Now, how are these two related? We've got shape A and we've got shape B. They're identical shapes, they're similar shapes. The area of A, let's suppose, is going to be 150 centimetre squared. And we've got to work out the area of B. Now, what do we know? Well, let's suppose we're going to be told some sort of relationship between the linear sizes. So I might be told, for instance, the length of this one is going to be something like 15, and the top one we're going to have some horrible number. Let's choose 67.5. It's actually not a horrible number. It looks it. But let's look at our linear scale factor. And this is going to be 67.5 over 15. And that's going to come out at 4.5. So our area scale factor is always going to be the square of that, which is going to be 4.5 squared. Perhaps not as easy as I wanted, but let's just go into the menu, choose number 1, and I want 4.5 squared. I didn't give myself such an easy one as I thought. 81 over 4, 20.25. So there is my area scale factor. Now, the area of B is going to equal my area of A, 150, times the scale factor, 20.25. And that one I will have to go to the calculator to do. 20.25 times 150. And that gives me the answer of 3,037.5 centimetres squared. So we've got a whole series of different shapes that we can do, and it doesn't matter what the shape is because they're areas, so it's always going to be a square. So not really too bad to try and work out. What happens, of course, if we've now, instead of got an area, we've got a volume? Well, we're going to do that in exactly the same way. We'll look at a simple volume. To look at a simple volume, let's take something that's going to be fairly easy to start with, and what I'm going to do is I'm going to use a right angle triangle. I'm going to start off with a nice right angle triangle, but we're going to make our life a little bit worse with this right angle triangle, because what I'm going to do is we're going to make it three-dimensional. So now I've got myself the sort of wedge of cheese, and I'm going to choose this one as a fairly nice easy one to try and help me, and I'm going to make this side 3, and I'm going to make this side 4, and I'm going to make this side 5, and because of the nice perspective here, we're going to make this side 5 as well. I know it doesn't look like it, but then we're just playing around with some maths. Let's compare this with another triangle, and if I draw in some sort of other triangle, let's make it slightly bigger. Did that brilliantly with my pencil. Slightly bigger triangle. Try and make it approximately the same. So we've got a slightly bigger triangle here. Let's make that side 8. Let's make that side 6. Let's make this side 10. And this one is also going to be 10. So this is A and this one's B. I've tried to keep a simple relationship here because I've tried to make this one double that side, and I've done that so we can see how they're similar. We look at our two triangles, we can see that they are similar triangles. The length of B is 2 times the length of A. So I've got a linear scale factor of 2. Let's look at my area scale factor. So my area scale factor is going to be, well, let's work out the area. The area is always going to be a half the base times the height. Let's work out each one of these. So this is going to be half of 3 times 4. So 3/4 of 12, divide by 2, gives me 6. So that's going to give me an area of 6 centimeters squared, compared with the other one, which is going to be 6 times 8, which is 48, divided by 2, which is 24. So now these are going to be related. What's the relationship between this? Well, it's going to be here 4 times. The linear scale was 2 times, and this is going to be 4 times because this is 2 squared. So if we now go along and look at the volume scale factor, we could predict maybe that if this is 2 to 2 squared, this may well be 2 cubed. Well, let's look at and see whether that's going to be true. So working out the volume of this, it's going to be the area times the cross-sectional area here times the length. We worked out this area as being 6, so this is going to be 6 times 5, which is 30, and the other one that we worked out is going to be 24 times 10, which is 240 centimeter cubed. We need to now work out how much larger this is than that. I'm not very good at dividing by 30, but I am good at dividing by 3, and here 3 into 24 is 8, so it's 8 times, and 8 times happens to be 2 cubed, so it does work. So let's have a look and see if we can try to do this with some other shape. See if we can work out this with something particularly horrible. Let's have a look at something like a cylinder. Let me draw in a little cylinder. Somewhat. I'm trying to use these templates to make life a little bit quicker, trying to do things, especially when I'm not particularly good at trying to draw. I don't think that was quite the same length. Let's make that about there, and we'll shove an end on it. So we've got two cylinders. We're told that these two cylinders are the same. We're going to give them names. We're going to call them A and we're going to call them B. And we're going to have a length here. Let's do the big one. Let's have a length of 25 centimeters. And what I want to do is I want to work out the height H of that cylinder. Now let's give us a relationship between these two. So let's suppose this one holds 60 and this one is going to hold, make a number up, 4. So what's the relationship between these? So let's look at the relationship of the volumes. So the volume ratio here is going to be, we'll do the largest divided by the smallest, which is going to be 60 divided by 4. And I've made my life reasonably easy because that's going to be 15. So the ratio of these is going to be a ratio of our basic volumes. There we are. Now if we want to look at our lengths, the ratio of those, it's going to be the cube root of 15. So that's going to be my ratio of my length. So let's go and look at what the cube root of 15 is going to be. So I want a cube root. I happen to have that one on this calculator, so I can do the cube root of 15, and that gives me a number 2.466. I'm going to use all the figures here until I know otherwise. Now this length here, H, is going to be smaller than that one, so it's going to be 25, not times, but this time divided by the length ratio, which is 2.466, or whatever the number was. So let's go back into the calculator, and I've got my number. It's going to be that number, so it's going to be 25 divided by my answer, which gives me here of 10.13. So if this one's 25, this one is going to be 10.13, and that one is 2. If we're going to put it in to be exact, if I want to do it to, what should we do it to, 1 decimal place? So that's going to be 10.1 centimeters. So I've now got a way of working out awkward lengths, awkward areas, and awkward volumes. I'm going to do one more to try and help you work out how we might do this. And when we want to try and do these, what we need to do often is know what our relationships are. So if we were doing cones, you'd need to know how to work out the length of something on a cone. You may want to work out the area of the cone, and you might want to be able to work out the volume of the cone. And this means you've got to know the formulas for doing these things sometimes. Well, let's try out a problem to see if we can work out one of these things, to work out something. Let's try something like a pyramid. Let's see if I can draw myself a couple of pyramids. The chances are here fairly low. So we're going to have two pyramids. Yeah, I think I'll draw underneath, it might be easier. Trying to make them about the same. And it's going to be somewhere up there like that, isn't it? See how badly I draw these sort of shapes. Yeah, you see what I mean? They're not very good. And let's look at then this pyramid A, this pyramid B, and let's give them some surface areas. So this one's going to have an area of 7, and this one can have an area of 112. What can I work out? Well, let's suppose we're told we've got the volume of A, and this volume's going to be, let's suppose it's going to be 36. So let's see what we can work out. Can we work out, first of all, the area ratio? So this is going to be 112 to 7, or 7 to 112. It doesn't really make any major difference, but I'm going to take here the larger one, I'm going to divide it by the smaller one. So I've got 112 divided by 7 is going to give me my ratio, and this is going to be here 16 times. Okay, so if that's the ratio of this, then what's going to be my linear ratio? Well, this is going to be the square, so it's going to be the square root here of 16. So they're going to be 4 times as long. So if there's going to be 4 times as long, then what's going to be the volume ratio? And I looked, I hadn't got the right bit there for you, sorry. So that was 16. Linear relationship is 16 divided by 4. Right, our volume ratio then is going to be 4 cubed. So 4 times 4 times 4, 64. Going to be 64 times. So if I've got this volume, the volume of B is going to be the volume of A times the scale factor. Which is going to be 36 times 64, and my maths isn't good enough to do that, so it's going to be 36 times 64, which gives us 2,304 centimetre cubed. Scale factors. They're not as bad as they seem. As long as you keep your wits about you. You have to try and remember the area ratio. That's always going to be the square. The volume ratio. This is always going to be the cube. If you want to go up from a linear, then you'll square it for area. Linear to volume, you'll cube it. If you have a volume, you want to go down to the linear, you will cube root it. Area, you will square root it. And as long as you remember that, it's not that difficult. If you found what we've done today quite useful, then please subscribe, and I will see you next week when we'll do some more GCSE Maths topic by topic. Take care. See you then. Bye bye.